talk a little bit about ratios. For example, if a person was to go online and research a recipe, say, for a very excellent Bailey's Martini, and they came across a recipe that said you should prepare your martini with an 8-to-1 ratio of Bailey's to vodka. Bailey's to vodka. What does that exactly mean? Well, a number of ways you could look at that. 8-to-1. We can write the ratio several ways. We can write it with the semicolon as I did. We can write it with the word 8 to, as in the word to between, 8-to-1. Or we can write it as a fraction, comparing two different numbers but the same unit. For example, if you're going to prepare a drink, that would mean for every 8 ounces of Bailey's, you would need 1 ounce of vodka. Let's just say that was a lot of liquor for one person. 8-to-1, that would be a 9-ounce drink. So say you wanted to break that down into a more reasonable size drink. Say you wanted to only put 2 ounces in your martini glass of Bailey's. To get from 8 ounces to 2 ounces, you could divide that by 4. So 1 divided by 4, write it as 1/4 ounce. Or you could write it as 0.25 of an ounce. Bottom line is this. Ratios compare two numbers with the same unit. Be very careful in how the question is worded. Because if I had said to you, this recipe requires a 1-to-8 ratio of vodka to Bailey's, and you put 8 times the amount of vodka and 1/8 of the amount of Bailey's, the drink would not be the same. So the first thing in your ratio has got to be the first thing in your word. Something to something. Write it as numbers, write it as words. But make sure that the first thing is always the first thing, and the second thing is always the second thing. When you rewrite your ratio as a fraction, then the first thing goes on the top, and the second thing goes on the bottom. And keep track of what that represents. Bailey's to vodka. So in my case, I would write on the left maybe a B over a V to keep it organized. Let's try that drink. It sounds delicious. Let's talk a little bit about rates. I'm going to use an example of an item from Costco. So you can get these drinkable probiotic yogurts, 24 of them, 24 Dan Active yogurts for a cost of $13.99. Our job is to figure out the rate and then the unit rate. If I was going to write the rate of these yogurts, I would put the cost on the top. $13.99 is the cost for the whole package, and that's for 24 containers, 24 bottles. That doesn't really have a whole lot of meaning. Most times you'll see on the label a unit rate, which is always the cost for 1 unit. To do that, you take the numerator, which is the money, divide it by the value. So $13.99 divided by 24 is going to give you the cost for 1 unit, in this case for 1 bottle. On the calculator, the answer is going to be 58.29, etc. That's obviously going to be, when you round the nearest cent, still going to say 58 cents. So 58 cents approximately per bottle would be the cost per unit of yogurt. That's called the unit rate. And unit rates are how you compare. So if you think you have a great deal at Costco, you find out, because it's a bigger package, you take the money value, divide by the number of units in your package, find the unit rate, compare that to the cost at another store sold in a smaller package to make sure that you are indeed getting a better deal by comparing the unit rate at each store. Let's talk a little bit about proportions. We actually use proportions when we set up our percent word problems to solve those. Let's talk a little how they work again. Say you had a proportion. Say you had something like 3 over 7, and you want to finish the other half of the proportion. Whatever you have for your second half of your fraction, if it's a true legitimate proportion, it's got to be equal to the first fraction. I'm going to make one up. I'm going to say 35 over 15. Now, if the question was asking you to prove that this fraction on the left, 3/7, was exactly equal to the fraction on the right, 15/35, you would have to do one of two things. Either take your two diagonals and multiply them and see if they're equal. So 3 times 35 is 105, and 15 times 7 is also 105. Since the diagonals are equal, then you know this is what we call a true and legitimate proportion. And the answer is yes, those are equal to each other. Anytime you solve a proportion, your job's always going to have one number missing. And then you need to figure out the answer to that proportion by cross-multiplying and dividing. Let's just say you had a proportion that was something like 21 over x. And that's equal to, so 21 over x, say, is equal to 7 over 8 rather. And your job is to figure out the value for x. To do that, you can look for relationships, and this one has an obvious one. I want you to see it. 7 and 21 differ by a factor of 3. So you should be able to predict the missing x value without using too much in the way of calculator skills. You could just do that in your head and solve x to be 24. If it wasn't a nice perfect number like this, what you can always resort to is the foolproof method of cross-multiplying the diagonal numbers, of which you have both. In this case, the diagonal of 21 times 8, and then dividing by the other diagonal number, which is across from your unknown. So 21 times by 8 divided by your 7, you're going to get the answer that x is equal to 24. So questions you're going to see, you're going to be asked to prove that the proportion is legitimate, perhaps. Do that by cross-multiplying and seeing if the diagonals are equal. And 99% of the time, you're going to be required to find the missing unknown in your proportion. They may or may not be simple. They could be a repeating decimal. They could be a fraction. But the way that you do those is to cross-multiply and to divide to solve for the missing unknown. The next video will have some practice answers from your booklet, questions 11 to 15. Thank you.